Okay, hello guys. We're going to go over the Chapter 9 quiz first. Okay, so here's the first question. So which of the following would be an appropriate null hypothesis? Again, I think there's a little bit of a lag. So if you have a question, I do have my eye on the little feed over here. So I might have to backtrack a little bit. But okay, so here's the first question. Which of the following would be an appropriate null hypothesis? So remember when we're talking about null and alternative hypotheses, it's always going to be about the population. So it's never going to be about a sample. So right off the bat, we can eliminate the option of B. So for a null hypothesis, we have three options. We can either have an equal sign, we can have a less than or equal to sign, or we can have a greater than or equal to sign. So those are only three options for the null hypothesis. So the correct answer in this case is that the mean of the population is equal to 55. If we go over to the mean of the population is greater than 55, this is more of an alternative hypothesis because we need that or equal to in order for it to be a null hypothesis. Okay. Question number 2. So if a test of the hypothesis has a type 1 error probability, an alpha of 0.01, it means that, so when you have a type 1 error, it means that you have a false alarm. So you're saying something is there when it's really not. So in this case, if the null hypothesis is true, you reject it 1% of the time. That's a type 1 error. A type 2 error would be this one right here. If the null hypothesis is false, you don't reject it 1% of the time. That's a type 2 error. If the null hypothesis is true, you don't reject it 1% of the time. That's not an error at all. So if the null hypothesis is true and you don't reject it, that's a correct decision. And if the null hypothesis is false and you reject it, that's also a correct decision. So for a type 1 error, that means that if the null hypothesis is true, you decide to reject it. Okay, so how many tissues should the Kimberly-Clark Corporation package of tissue contain? Research determined that 60 tissues is the mean number of tissues used during a cold. Suppose a random sample of 100 tissue users yielded the following data on the number of tissues used during a cold. So there's our sample. We have 52 tissues with a standard deviation of 22. Suppose the test statistic falls in the region of rejection at an alpha level of 0.05. Which of the following is correct? So hopefully you have seen, let me open this up here. Hopefully you've seen these helpful hints over here in Chapter 9. Okay, so here's helpful rules of thumb. And this can help you make a decision based on the problem here. So let's go back to our question. And it says, suppose the test statistic falls in the region of rejection. Which of the following is correct? So it does fall in the region of rejection. Uh-oh. I think we actually have the wrong answer here. Uh-oh, guys. Hopefully this didn't confuse you. If it does fall in the region of rejection, there should be sufficient evidence that it is not. So this should actually say sufficient. Oh no. So let me change that there. Okay. Well, it's a good thing we're going over this. It looks like we found a slight error. All right, so if you go over here, this is what you want to go by. And so if it is in the region of rejection, then we're going to reject the null. And if we reject the null, then we have sufficient evidence to say that the null is not true. So going back over here, suppose the test statistic does fall in the region of rejection. So we're going to reject the null. Which of the following is correct? That we have sufficient evidence to say that the null is not true. So this is why this one is correct. Sorry about that, guys. All right. So here's the next question. A pizza chain is considering opening a new store in an area that currently does not have any such stores. The chain will open if there is evidence that more than 5,000 of the 20,000 households in the area have a favorable view of its chain. It conducts a telephone poll of the 300 randomly selected households in the area and finds that 96 have a favorable view. State the test of hypothesis that is of interest to the pizza chain. Okay, so we are looking at a proportion here rather than the number of households. So we're going to be looking at 5,000 divided by 20,000. So if this is what we're trying to prove, that the chain will open if more than 5,000 of the 20,000 households have a favorable view of the chain, that becomes our alternative hypothesis. So here's where we have the proportion is greater than 0.25. And then our null hypothesis is just that the opposite. That is less than 0.25. Okay. So here we have a marketing manager of an automobile manufacturer is interested in determining the proportion of new compact car owners who would have purchased a GPS navigation system if it had been available for the cost of $300. The manager believes from previous information that the proportion is 0.3. Suppose that a survey of 200 new compact cars is selected and 79 indicate that they would have purchased the GPS navigation system. If you were to conduct a test to determine whether there is evidence that the proportion is different from 30 and decide not to reject the null, what conclusion could you reach? Okay, so if we are not going to reject the null, then we have insufficient evidence. So going back to our rules over here, if we are not going to reject the null, we have insufficient evidence. So right off the bat, we can cross off two of these, right? Because these, A says sufficient evidence, C says sufficient evidence, and B and D say not sufficient. So we're either looking at B or D. Remember that we would have insufficient evidence to say that the null is not true. So which is the one that says that the null is not true? The answer is D. There is not sufficient evidence that the proportion is not 0.3. Okay, I don't see any questions so far, so I'm just going to move on. If you do have a question, please just go ahead and put it in that chat. So here's the next question. A drug company is considering marketing a new local anesthetic. The effective time has a normal distribution with a mean of 7.4 minutes and a standard deviation of 1.2 minutes. The chemistry of the new anesthetic is such that the effective time should be normally distributed with the same standard deviation, but the mean effective time may be lower. If it is lower, the new drug company will market the new anesthetic. Otherwise, they will continue to produce the older one. A sample size of 36 results in a sample mean of 7.1. The appropriate hypotheses are. Okay, so when you're trying to determine these null non-alternative hypotheses, you can either ask yourself for the null, what is the status quo, or for the alternative, what are you trying to prove? So in this case, you could really either go with either. So I'm trying to say that this new anesthetic is going to be less than the previous one. So that's why my alternative is going to be, hello, I have no audio. Can you guys not hear me? Okay. All right. I'm not sure who YHB is. Hopefully you have your speakers figured out, but it looks like audio on my end is okay. All right. So where were we here? Yes. So the alternative hypothesis is that their mean is going to be less than 7.4 because that's what we're trying to prove. Okay, great. So once you have your alternative hypothesis, then you can just take the opposite for your null hypothesis, and that your mean is greater than or equal to 7.4. Okay. So which is the following is not true about the level of significance of a hypothesis test? The larger the significance, the more likely you are to reject the null hypothesis. The level of significance is the maximum risk we are willing to accept in making a type 1 error. The significance level is also called the alpha level, or the significance level is another name for type 2 error. So this last one is an incorrect statement. The significant level is another name for type 1 error, which is also known as your alpha. So significance level of the test, type 1 error, alpha level, those are all synonyms. Okay. All right, so here we have a printout. We're looking at defective items, defective light bulbs. And we want to know if the mean number of defective light bulbs is greater than 20 during the morning shift. She will make her decision using a test with the level of significance at 0.1. Okay, so we only have our level of significance, which is 0.1, which is also our alpha. And going back to our rules of thumb over here, if your p-value is less than your alpha, then you're going to reject the null. If your p-value is greater than your alpha, then you do not reject the null. So we would need to find our p-value. Here is our p-value here, and it's 0.021. So is our p-value less than our alpha? Is 0.02 less than 0.1? It is, so we're going to reject the null. We could also use the critical value and the test statistic to make our decision as well. So here's our critical value. That tells us, that divides our distribution into our regions of non-rejection and our regions of rejection. And then here's our test statistic of 2.09. So 2.09 would be in the region of rejection, so we'd also reject the null here. So two ways that you could have figured out to reject the null would be to look at the p-value and compare it with your alpha, or you could look at your test statistic and compare it to your critical value. Okay. Now we want to know what the conclusion is. So we can conclude if we're rejecting the null, we have sufficient evidence to say that the null is not true. So that is a true statement. Okay, and the last question here. So you have created a 95 confidence interval with the mean. With the result of 10 is less than or equal to, or the mean is less than or equal to 15, but greater than or equal to 10. So somewhere between 10 and 15. If we have the null hypothesis of the mean is equal to 16, what should our decision be? So remember, with the confidence interval, we are 95% confident that we have the true population parameter, the true mean, somewhere within this interval. If we're trying to say, is our mean 16, since 16 is not in this interval, we can reject this null. We're going to say this statement here is most likely false. If I were testing the null hypothesis that the mean is equal to 13, then I would not reject the null. So these are actually the same answers here. So do not reject the null or fail to reject the null. That means the same thing. Okay, so that was Chapter 9 quiz. Do you have any other questions about Chapter 9 quiz? I can start to go through the practice exam. Okay. Of course. No problem, Rachel. All right. I'm glad we went through it because we caught that one error. Okay, let's see if we can make this a little bigger. All right. Is there any specific practice exam questions that you want me to go through, or do you want me to start from the beginning? Number 7, practice exam. Number 7, question 10. Okay, are you saying that number 7? Okay. Here's number 7. I think that's what you mean, right? Is that question number 7 and question 10? I hope that's what you mean. The probability that a new advertising campaign will increase sales is assessed at being 0.85. And the probability that it will decrease in sales is 0.1. What is the probability that sales will remain unchanged, assuming that these are the only 3 possible outcomes? Oh, okay. Sorry about that. The chapter 7 quiz, question 10. All right. So I think mine are a little bit out of order. Can you give me what the question starts with? Because I'm not sure if it'll be in the same order as your question 10. So this is my question 10. The manufacturer of power tools claims that the mean is, okay. All right. So manufacturer of power tools claimed that the mean amount of time required to assemble their top-of-the-line table saw is 80 minutes with a standard deviation of 40 minutes. Suppose a random sample of 64 purchasers of this table saw is taken. The mean of the sampling distribution of the sample mean is, okay, so in order to answer this question, you do have to understand what a sampling distribution is. So if you remember from our Reese's Pieces incident over here, bring this up here. Okay, so suppose that we are trying to find the proportion of orange Reese's Pieces in this population. So I'm going to take a sample of 25 candies. Here's my sample of 25 candies, and it comes out to 0.48. So there's our one sample, and I've graphed it down here, or it's been graphed down here. There's our one sample of 0.48. I could take another sample. There's 0.52. There it is. I could take samples over and over and over again. So a sampling distribution is if I were to take samples, all possible samples of a population, what would it look like? So I took a sample again of 25, comes out to 0.64, and it's been graphed down here. So suppose I take 1,000 samples of 25 candies each, and it's been graphed down here again. So as you can see, it starts to look like a normal distribution, right? Sometimes we could get a sample of 25 Reese's Pieces that has only 10% orange. And sometimes we could get a sample of Reese's Pieces that has 85% orange. So sampling distribution is if I were to take all possible samples from a population of a specific size, so in this case it would be 25, what would that look like? This would create our sampling distribution. And if you imagine, if we were to take the mean of all of our samples, so I add up all of these proportions, and then I divide it by the number of samples that I have. In this case, I would have 1,012 samples. The mean of all of my sample proportions that I've taken would equal the true population parameter. So again, if I were to take the mean of each of these samples that I've created, it would equal the true population parameter. In this case, I did specify that the true population parameter is 0.5. And you can see that, if I were to take the average of this, it looks like, the middle is going to be around a 0.5 as well. So your population mean, or your population parameter, is going to be equal to the mean of all the means in your sampling distribution. So going back to this question here, suppose a random sample of 64 purchasers of this table saw is taken. The mean of the sampling distribution. So again, if I were to take all possible samples of size 64 and then take the mean of all of those samples, it's going to equal the true population parameter. And the true population parameter is 80 minutes. So the answer is 80 minutes here. Okay. What are the questions you guys have? I hope that helps. Let me know if you need further clarification. Pizza chain. Chapter 9 quiz. Pizza chain. Are you sure that's chapter 9? We just went over chapter 9 quiz. I don't think we had a pizza one on there. Oh, maybe we didn't. I think we did. So let me go back. So a pizza chain. Okay, here we go. I found it. All right. So the pizza chain is considering opening a new store in an area that currently does not have any such stores. The chain will open if there's evidence that more than 5,000 of the 20,000 households in the area have a favorable view of its chain. It conducts a telephone poll of 300 randomly selected households in the area and finds that 96 have a favorable view. State the test of hypothesis that is of interest to the pizza chain. Okay, so you first want to do a proportion because, we're not going to be sampling 5,000 households. We've only sampled 300 households. So the only way that we could say that probably 5,000 of the 20,000 households is interested in having this pizza chain is if we do a proportion. So 5,000 of the 20,000 would be 25% of the households. So basically what we're trying to say is if there's interest in greater than 25% of the households, then we'll open up a new pizza chain. So again, you want to consider those questions about the null and alternative hypothesis. Your alternative hypothesis is typically going to be what you want to prove, or if this occurs, then something will change. Whereas your null hypothesis is going to be the status quo. So because we're going to open something if there's greater than 25% of the households that have an interest in the pizza place, that becomes our alternative hypothesis. Pi is greater than 0.25. And then our null hypothesis is just the opposite of our alternative hypothesis. So it's less than or equal to 0.25. It's not this option here of 0.32. I believe 0.32 ends up being, if I did 96 divided by 300, yeah. So it's not 0.32 because remember we're looking at the population, and that 0.32 is the proportion of our sample. It's not 5,000 because again, we are trying to find, this is our population, and our sample, we're looking for the proportion rather than the number of households, because we're not going to be sampling the entire population. Great. All right, and then exam review number 20. Okay, referring to the scenario in 19, what percent of the samples are likely to have less than 37.5% who take advantage of online customer service? Okay, so going back up to 19. So online customer service is a key element of successful online retailing. According to the marketing survey, 37.5% of customers take advantage of the online customer service. Random samples of 200 are selection. The population mean of all possible sample proportions is what? Okay, so there's our scenario. The answer to 19 is B. So what percent of samples are likely to have less than 37.5 who take advantage of the customer online service? So this is kind of, this one's a difficult question because it's combining what we're learning about sampling distributions and then what we learned in the past about the empirical rule. So if we know that this is our sampling distribution, where the mean of our sampling distribution is 37.5, so what percent of samples are likely to have less than 37.5 who take advantage of the online customer service? Well, it's going to be this half of the distribution, right? And we know that that is equal to 50%. Sometimes we forget, you know, it's like, well, I don't know how to figure that out. You do know how to figure it out. Okay, what other questions do we have? $29. Okay. And 30. All right, so these are all about confidence intervals, I think. So what percentage of online adults use social networking? A recent study revealed that yada, yada, yada. It also revealed that 72% of men. Okay. So a 95% confidence interval was computed for the population proportion of college graduates who use some form of social networking site to be between 0.705 and 0.7525. So true or false? It is possible that the 95% confidence interval calculated from the data will not contain the population proportion of college graduates who use some form of social networking. So this is true. And why that's true is because we have to go back to what a confidence interval is. So remember that when we take a sample and we get a point estimate, it may not truly reflect the population parameter. And so we create confidence intervals to try to account for that sampling error and say, all right, our population parameter may be somewhere between here and here. Now, what that 95% confidence refers to is the idea that if we were to take samples over and over and over again and create confidence intervals for each, then 95% of those confidence intervals would contain the true population parameter. So here's our sampling distribution. Remember, this is a sampling distribution. And suppose that our true population parameter is 0.73. So we're trying to estimate this 0.73, right? So we take a sample and we get a point estimate, and from that point estimate, we have a confidence interval. So in this case, from our one sample, we have from 0.70 to 0.75, something like that. Now, if we were to take another sample and say it comes out to be 0.71, I can create a confidence interval. Remember, that confidence interval is based upon your confidence level as well as your standard error. You can create a confidence interval, and hopefully the true population parameter is caught in this confidence interval. If I were to take another sample, maybe it's all the way out here, and I create a confidence interval, hopefully, again, the true population parameter is captured within our interval. So it is possible that you could get a sample that's way out here in the tail end. Okay, even if I create a confidence interval, our true population parameter isn't contained within this interval. But with the 95% confidence interval, that's saying if I were to take all possible samples and create a confidence interval for each sample, then 95% of these intervals would contain the true population parameter. We have just one interval here. So 0.70 to 0.7525, that's our one interval. And we have a 95% chance that we have one of the intervals that contains a true population. It's possible, it is possible, right, that we could get a sample that's out here in the tail end and we create a confidence interval that does not contain that true population parameter. So this is a true statement here. It's possible 5% of the time we would get an interval that does not contain the true population parameter. And 95% of the time we would get an interval that does contain the true population. So that's why that answer is true. Number 30, so it is possible that the 95% confidence interval calculated from the data will not contain the sample proportion of college students who form some social networking. So this is a false statement because of this word right here. Our confidence intervals are looking at the population parameters and not our samples. Okay, hope that clears that up, Rachel. Okay. The standard error of a mean for a sample of 100 is 30. In order to cut the standard error of the mean to 15, we would. So this is really just an algebra problem. So your standard error is equal to the standard deviation divided by your square root of n. So it says the standard error for the mean for a sample of 100 is 30. So there's our standard error. Is equal to our standard deviation. We don't know what our standard deviation is. Divided by the square root of 100. So this gives us a standard deviation of 300. 30 times 10. Okay, now that we have the standard deviation, in order to cut the standard error to 15, we would, so now we want 15 is equal to, our standard deviation is 300 divided by the square root of n, and then we just solve for n. You can't see the problem. Which problem? Okay. What other questions do you guys have? Oh, how to solve for n? I can do that. Sorry about that. I kind of just stopped here. So we're just going to use some algebra here to get n by itself. So 15 times the square root of n is equal to 300. So your square root of n is equal to 300 divided by 15. So the square root of n is equal to 20. And then to get just n. We're going to square it. And we have to square both sides. So our n is equal to 400. So in order to cut our standard error to 15, we would need to increase our n to 400. Yeah, of course. So, yeah, I don't know if the lag might be different. Anybody have any other questions? Chapter 7, quiz, true, false, bleach. Okay. True, false, bleach. Okay. Come on. Okay, so the amount of bleach a machine pours into bottles has the mean of 36 ounces, standard deviation of 0.15 ounces. Suppose we take a random sample of 36 bottles filled by this machine. The sampling distribution of the sample mean will be approximately normal if the population sample is normal. So the thing we want to pay attention to here is these two little words. So only if the population sample is normal. Our sampling distribution of the mean will be approximately normal, no matter what the shape of the distribution is, because we have a sample that is greater than 30. So if we have, as long as we have a sample that's greater than 30, then our sampling distribution of the mean will always be normally distributed. It doesn't matter if our population is left skewed or right skewed or uniform or bimodal or something crazy like that. As long as we have a sample size that's greater than 30, then it will be, the sampling distribution will be normal. If we only have, if we have a sample size that's less than 30, say we're only looking at 15 bottles, then this would be a true statement. So suppose we take a random sample of 15 bottles, the sampling distribution of the sampling mean will be approximately normal only if the population sampled is normal. Okay. Anybody else have questions? Practice exam. Chapter 8 quiz. The university is interested in determining. Okay. Okay, so university dean is interested in determining the proportion of students who receive some sort of financial aid. Rather than examine the records for all students, the dean randomly selects 200 students and finds that 118 of them are receiving financial aid. The 95% confidence interval for this is 0.59 to plus or minus 0.07. How do we interpret this interval? Okay. So we see the correct answer here. We are 95% confident that the true population proportion of all students receiving financial aid is between 0.52 and 0.66. So that is true. Remember, with a confidence interval, that 95% refers to if we were to take a bunch of samples and create confidence intervals for each, then 95% of those confidence intervals would contain the true population parameter. So the one that we have, which is 0.52 to 0.66, we're 95% confident that the true population proportion is somewhere in there. So that's a true statement. Now let's look at why the rest of these are false. So 95% of the students get between 52 and 66% of their tuition paid for by financial aid. So that is an incorrect statement because, again, that 95% refers to the 95% of intervals. That 95% doesn't pertain to the specific interval that we got with our one sample. We are 95% confident that between 52 and 66% of the sampled students receive some sort of financial aid. So that question is incorrect because confidence intervals refer to the population parameter, and this is talking about sampled students. So we know what sampled student, what our sample got. We're trying to estimate the population parameter with our 95% confidence interval. And then we are 95% confident that 59% of students receive some sort of financial aid. So that's basically our point estimate. And we're not 95% confident about that. We're 95% confident that the true population parameter is between 0.52 and 0.66. It could be 59%, but it could equally as likely be 0.53%. I'm sorry, 53%, not 0.53%. Yes, of course. Do you have any other questions? Does anybody else have any other questions? Anybody else have any questions? Practice exam, quizzes. Even final project. Questions, anybody? Okay, well, I'm going to sign off here unless somebody else has any other questions. Okay. Yeah, so for the practice exam, let's see. So, oops, those are the answers. So the practice exam does have some of the previous questions on here, so that'll help you review. Okay, any other questions? All right, guys, I'm going to sign off then. If you have any other questions, please just send me an email. We will probably do another YouTube Live again before the last exam. So I'll likely send out another doodle poll to see what time would work most for most. All right. Well, if there are no other questions, then have a good night, everyone, and let me know if you need anything. Bye-bye.